The flight time mainly depends upon the battery. If we use a 22 milliamp hour battery, it gives around 15 to 20 minutes flight time.
Akshay Kaul, who made tilt-rotor micro-air vehicle, said that his flight can fly for 5 minutes and it can be improved further. He said that micro-air vehicle can work as a helicopter and as a flight. Kaul explained that the micro-air vehicle can go vertically and horizontally in the air.
My name is Akshay Kaul and I'm a student of JNTU-H Mechanical Engineering Department, and this model, my model's name is, the title of this model is tilt rotor. So it basically works on a simple mechanism that it is a VTOL type, that is a vertical takeoff and landing type aircraft. Now the mechanism involved here is that it takes off vertically. So it's not like a conventional aircraft that runs on the runway and needs some thrust for that. No, it takes vertically off, and then to change the propulsion, all we need to do is to tilt the rotor in the forward direction to get the forward propulsion. And for the pivotal mechanism here, I've used a simple mechanism, and this mechanism is actually based on super glues and carbon fiber tapes along with the metallic servos. So the servos really work it helps the whole device to move in a specific direction. Now the rolling is that like this in this motion. It is done by varying the speed of both my rotors. And then if I have to move forward, all I have to do is to shift these two by my RC and it will start moving forward. Now if I have to move backward, the same thing, just in the opposite direction. And the yawing motion, that is this motion, is controlled by this. You have to give it a perpendicular planes, like you have to shift it and you get this sort of motion. So this is yawing, and the rolling I already told you, and then I have pitching, which is normally like this. And this is my KK board. This board acts as a gyroscope. Now what a gyroscope is actually is that it controls my flight. Now when I'm controlling it with my RC, if I give a throttle with on one stick, I have to control. I need both of them to rotate on a similar pattern at a similar speed. So that is done by my RC, by my gyroscope, which is the name of this thing is called the KK board. This thing here is the receiver unit, which takes the signals from my RC. And here's my battery. The battery is quite heavy. It's 220 mAh battery, and then the motor itself has a thrust capacity of about 1 kilograms. So the total weight of the aircraft is about 562 grams, including everything. And I have used electronic speed controllers just beneath here. They control the speed of the whole thing. When you're giving it a certain propulsion, this is the thing that takes the input from the battery and gives it to the motor. And I have connected that to the receiver and again to the servo board because it needs to be connected. That's all about my design and overall.
How many minutes it can fly?
In about 5 minutes, some 30 odd seconds.
Can it be extended?
It can be, yes. I have to use either bigger battery or to change the dimensions of the whole thing, get it aerodynamically effective, or again use a bigger device. But then again I have to compromise the weight on that thing, so I can't do that. So it has to be somewhat optimal. So this is the best I can get. Something I am more involved towards automobile sector. So aeronautics was something new to me and I took it as a challenge. So I think what else, I'll try to learn from this. Because
you want to go into R&D of this?
Absolutely, I would love to work in an R&D department rather than being in the sales or something else. So that should help.
Who has guided you in this project?
Guidance was from almost everyone. Like the most important guide was the internet. You get everything from the internet, and then there were people, the professors from IARE college, and then our own professors. So they have really helped us.
How many feet it can fly?
It can go about 20 feet.
What are its applications?
Again, the applications in defense. So right now for stealth missions, let's say they can use it in defense, you can use it in traffic control, you can use the MAVs everywhere. Most of the applications of MAV are almost same. You can use them while you're in the, like if you have to survey certain traffic, you have to survey some hostile areas or some areas where you can't go. You can use these sort of things. Now the thing with this is that you really don't need it to give an initial thrust or something. It can carry itself like it's a helicopter, and then it has a better speed, better control. I wouldn't say control completely, but yes, it's much more stabilized and it uses less devices than a normal quad rotor or any other MAV. So it has
How
a
many
good.
times you have tested it?
About I'll be honest with you, I made around 6-7 models before finally I came on to this thing. I used balsa wood first, then I used other frames, I changed my frames. Finally I went with a simple frame, that is first I went with a box, and then I somehow sorted the center of mass somewhere at the center, and then I created the platform, the wing platform. And then the most important part was the pivotal mechanism that I need to install for the pitching. So that was really important, and I did that. So it took time a little, but it worked.
How do you see the future of this type of?
It's very vast. India is still lacking in this thing. I mean, we are coming up with certain ideas, all right, but this thing is, we are getting used to it, or I mean, people are now knowing about it since we have a lot more conferences and symposiums, and people are becoming aware about these things. Because if you really search on the net and you get certain idea that people outside at the age of 7, at the age of 13, 14, they already made this thing, and they are participating in various sort of competitions. Whereas here we are aware of these things. We are getting to aware of these things when we are about in our college or when we are in school. So that is certain thing where we are lacking, and we hope that the coming generations, like I started it, my juniors, I would really install the knowledge in them about this, and I would really want to share with them. So maybe they can get excited about it, and maybe they should go in a different way and a positive way.
Since how many years it is getting the focus in our country?
I am not exactly sure, but yesterday I attended the conference and they said we are making this since 1970s. So they are developing these designs, but somehow Israel is quite good in MAVs. And if you look into the defense purposes, they really would want to import rather than because the quality outside is definitely better. We are still doing the R&D, which should really help us. And I think now the defense really wants some sort of level from our industry so that we can build up. So it starts from the basic stage, that is, starts from the student itself. We people will start it, then only we'll have certain knowledge and we should carry on further.
Since how many years in our country it is getting?
I just said, I heard, I am not sure, it may be 1970.
Thanks. Mazhar Khan, a technician